Hey guys, this is lecture video 6 of CSE2000Q2S, Computer Science 2, taught by Lawrence Orijuela, and my name is Lawrence Orijuela. Today we are going to be learning about structs and classes. So if you look at the tentative schedule, we are moving as planned. Today is October 2nd. We're actually going to spend 2 weeks discussing structs and classes, but that's actually going to get interrupted by midterm review. And then next week, I'm not going to have a normal lecture video. Instead, I'm going to have a video where I do all of the questions of the practice midterm for you. Okay? Now, you have 2 items due tonight. The first one is your activity 5, which covers pointers and iterators. So make sure you do that before midnight tonight. And the other item that's due is your lab 2. Okay? Which covers user-defined functions and arrays and vectors. Okay? Now, for those of you that need help with Lab 2, if you go over to the Blackboard over here, if you go to Labs, you'll see a video of our Lab 2 meeting, which we had on September 25th. And I posted this video here for those who missed the Zoom meeting in which we discussed this and actually finished this. So if you need help in Lab 2, please refer to this video here. It's quite helpful. Okay? So aside from that, let's actually get down to lecture material now. Okay. So the first thing I guess I'd like to discuss is what we're going to be doing for these next couple weeks, okay? So, in case you didn't know, I took a lot of time to try to figure out the best way to execute these lessons, okay? So, we are currently on week 6 right now, which is Structs and Classes. Now, here's the thing. Classes take a very long time to write, okay? And I know that this class is supposed to be a supplement to CSE 201, and in 201, one of the big things that you need to learn is classes. You cannot get by as a C++ programmer unless you knew classes, okay? Now, I know I said in the tentative schedule that we take 2 weeks to cover classes, well, and structs, of course, but here's the thing. So week 6 is all about classes, week 7 is the midterm. Week 8, we continue where we left off with classes and talk about constructors, okay? Week 9, we talk about inheritance, which is a feature of classes. So the inheritance is actually an extension of what we learn in weeks 6 and 8. And then overloading, operator overloading, that is also an extension of classes. So the truth is, we take 4 whole weeks talking about classes alone. And that's a long time. That actually takes up a huge chunk of our tentative schedule. And due to the fact that we only meet once a week, I was really scratching my head on about how I wanted to give you assignments and teach this to you. And it's actually because of that. Because of how long it takes to write a class, I actually decided to have lecture activities 6 through 8 and Lab 3 build on top of each other. So if you actually looked at Lab 3... Now, Lab 3 actually isn't going to be due for a very long time if you go back to the tentative schedule. Yeah, Lab 3 is due over a month from now. But if you actually go to Lab 3, I'm going to pull this up again on Blackboard. So if you read it, Lab 3 covers classes, inheritance, and overloading. So this program simulates a school database that stores the information of students and faculty. To finish this lab, you must do the following: add 2 new text files to the program called faculty.txt and students.txt. You'll find these text files in Blackboard, and you'll find them here, right there, and here. Okay. 2. Add the 3 header files, persontype.h, studenttype.h, and facultytype.h that we finish/will finish by the time we complete lecture activity 8. 3. Run the program and play with it. See how it works and take a screenshot. Now, depending on whether or not you've done lecture activities 6 through 8, this could be the easiest or the hardest lab for you. So, if you've done lecture activities 6 through 8 successfully, you basically finished your lab 3. All you have to do is add the text files and add the header files. Now, in order to demonstrate just how powerful classes are, because we are taking 4 weeks on this, I actually took the time to pre-write a demo program that uses those 3 classes that we write. This program actually simulates a school database, okay? And yes, I actually did write all this, okay? I took a good while to think about how I wanted to do this because, again, this class is very short, and I couldn't ask you to write something like this because you guys are just beginner programmers. Like, you need some time in order to come up with this. But if you took time to look at this demo program, you'll see that there's nothing in here that you haven't already learned. Well, there is one thing you didn't learn yet. It's classes, inheritance, and overloading. But we will get to that eventually. But after this, after you complete your lab 3, one thing that I'd like you to do is just read this program and try to see how it works, okay? Because this is the kind of thing that you're going to be writing if one day you get hired as a software engineer for a big software company, okay? But enough of that. Let's put this back over here, okay? Now, so yeah, because of that, I decided to combine these. That's the main thing you need to take away because classes take a long time to write. But anyways, yeah, one thing that you need to expect is that these next couple weeks, they're going to get pretty hefty because we're talking about classes. And, you know, that's perfectly fine. Like, being a programmer is quite difficult. But if you stick with me and you do the work, you and I will accomplish a lot. You are going to learn a lot. Okay? So let's move on. So the first thing we need to learn is structs. So the reason why I wanted to teach structs first, I don't think you ever learned structs in CSE2001, but the reason I wanted to show it is because it's very similar to a class, and I would like to think of this as a stepping stone for when we eventually talk about classes, because classes are huge, okay? So, a struct is another form of structured data type. Now, you already seen this table before, okay? Now, we have simple data types, which is here. Structured data types, 2 of them we learned already. 2 of them we'll learn today. And then there's pointer variables, okay? Now, the 2 structured data types we already learned last week were array and vector, okay? Now, as useful as arrays and vectors are, they have a limitation. They can only hold multiple members of the same data type. So, you noticed this when we were doing the lecture activities for the last lecture. When we wrote an array, it was either an array of ints or it could be an array of strings. For vector, we made a vector of strings called fruit names. Do you remember that? That's the problem. They can only hold members of the same data type, okay? Structs and classes are structured data types that can hold members of different data types. So it doesn't have to be all strings or all ints. you could have one member that's a string, one member that's an int, and so on. And the way that we do it is that we would define what these structs or classes are. And I put a little note on the bottom here. I like to think of structs as a less powerful version of a class. Okay? So bear that in mind. So the syntax for a struct is shown like this. You need the keyword struct. You need a struct identifier, which is pretty much the name of the struct that we're creating. And now we can assign multiple data types to the struct. So you see we have data type 1, data type 2, identifier 1, identifier 2, all the way ... to identifier n. We can have as many members as we want in the struct, okay? And they can be data types of anything we want, okay? So when you write this syntax, the best place to write it is between your using namespace standard and your int main. We'll demonstrate that eventually. So when you define a struct identifier, which is what we name it, becomes a new data type that the compiler will recognize. That's really powerful, okay? Now, the objects in the struct are called member variables. I think I mentioned that already. And if you wanted to access the members of a struct, what you would do is write the name of the struct that you wrote, that's of type struct, and then you use a period, right? You put the period right there, and then you say the identifier in which you wish to access, because they're listed here. You have identifier 1 and 2 all the way to n. We can access them using a period, okay? Now this period, some books call it the member access operator. Other books call it the dot operator. But either term, they're both correct, okay? So here's where you can see that where structs can become very, very handy. So imagine this. Imagine a souvenir store sells shirts for $10 and they have 20 of them in stock. They sell pants for $15 and they have 25 of them in stock. And they sell shoes for $20 and they have 30 of them in stock. Now let's say that this souvenir store hired you to write a computer program that keeps track of their inventory data. How would you do that? Okay. So, if you didn't know about structs, probably one idea that would come to mind is to make 3 arrays like you would here. So, maybe you could make a string called item names, make it size 3, make it a size 3 array, and then put shirt, pants, and shoes in there. And then have another 3-member array of type int. Put the quantities in there because there's 20 of them, 20 shirts, 25 pants, and 30 shoes. And then make a third array of doubles, and that's also 3 items long, and have it contain the prices. So shirts are $10, so you put 10 there. Pants are $15, so you put 15 there. Shoes are 20, so you put 20 there. But if you think about it, this is a really cumbersome and really inefficient way of storing our data. A better way to store our data would be to group it so that shirts 20 and 10 are items in one container. Pants 25 and 15 are objects in another container, and then shoes 30 and 20 are objects in another container. That would be a better way to do it. So, a better idea than this, okay, would be to contain the data in a unique struct and then store them in a vector. Because think about how you would do it if you did do it this way if you made 3 arrays. Let's say that the program needs to if you wanted to change the price of pants from $15 to $17, what you would have to do is traverse the item names array until you find pants, keep that position, and then go over to the prices array, travel to the position where you found pants, and then change 15 to 17. And that's really cumbersome, okay? And then what happens if you sell items? Like, let's say you sold a pair of shoes, right? You would have to find the position where shoes is in the item names array, and then keep its position, and then traverse this array until you find the same position, and then take 30 and subtract it by 1. That's very inefficient. So writing a struct is better. So we are going to begin with the lecture activity, and we are going to create a struct called store item. Okay? It will contain a string called item name, an int called quantity, and a double called price. Okay? So let's exit and open Visual Studio. Create new project, C++. We'll save this where we usually save it, right here. We will call you lecture activity 6. Now, one thing that you might notice about this video, if you look at the time, yes, I am recording this video past midnight. This is the life of a master's student, a computer science master's student who's also teaching a class. Okay, and you know, I believe in transparency. Another truth is I'm actually going to meet with some professors tomorrow in regards to my master's project. So if anyone out there decides to go get their computer science master's degree like me, you are you're probably going to do the same work that I am right now, like pulling all-nighters like this. But let me just take a moment to say that even though this is a lot of hard work, like I wouldn't have it any other way. I really like my job as a professor, and I really like being a master's student for computer science in this school. So when I'm recording this late at night, I don't mind at all. Just thought I'd share that with you. So anyways, let's get down to business. We need to write our normal C++ jargon. So I'm going to say include iostream using namespace standard int main. Okay. Now, if you go back to the PowerPoint, I did say something before. It's best to put this syntax for a struct between your using namespace standard and your int main. Okay? So I'm going to go in between these lines, and I'm going to define my struct. So this is the syntax is right here. We have struct identifier, and then we list our identifiers. Okay? So I'm going to say struct, and we're going to call it store item. Store item. Truthfully, we can name this struct anything we want, but store item is easy to remember. Okay? Now, we need a string called item name. We need an int called quantity, and a double called price. Okay? And I believe that's what it told us to, right? Yeah. So, okay. Let me see. Okay, so our data is right here. If you look at this PowerPoint, let me just. So, shirts, we have 20 of them and they're $10 each. Pants, there's 25 and there's $15 each. Shoes, there's 30 of them and they're $20 each. So, now that we have our struct syntax made, we're actually allowed to use it now. So, here's what I want you to do. Over here in your int main, I need my return 0, my bad. In your int main, we're ready to begin using this newly made struct, okay? So let's do this in parts again. Cout a creating and using a struct. Okay. Now, I'm gonna put a comment. I'm gonna put a comment for each of the 3 store item variables that we create. Okay, so I'm gonna say create and initialize a store item shirt. Okay, so the first thing we're going to do is create a store item just for shirts. So we're going to declare a new variable of type store item, okay? And we're going to call it, let's call it item 1, okay? Now, you can see that I put store item here and then I have something here, right? So what happened as a result of us writing this is that store item is now a valid data type that the compiler recognizes. So if you recall before, we were creating variables like string name and int age, you know, things like that, where this is the data type and this is the data is the variable name. This is the data type, this is the variable name. It's the exact same thing here. Store item is now a valid data type, and the variable name is called item 1. Okay? So how cool is that? So structs, classes too, they're very powerful if you know how to use them correctly. So now the problem here is that item 1 is uninitialized. So item 1 has 3 members, right? Right now, these 3 variables that it contains, they're not initialized to anything, so we're going to have to initialize them. And if you recall from the PowerPoint, the way that you would access them is using the dot operator. So you put the name of the struct dot identifier. Okay. So here's what we're going to do. We're going to say item 1 dot. And now over here we have a list of options. We have item name, price, and quantity. We want to set item name to shirt. Okay. And we're going to do it again. Item 1 dot. We're going to take quantity and set it equal to. What was it again? I'm going to have to look. Quantity is 20 and then the price is 10. Okay. So quantity is going to be equal to 20. And then item 1 dot price will be equal to 10. Okay? So this store has 3 items, okay? Let's write 2 more struct objects that contain the data for the other 2 objects, which is pants and shoes, okay? I'm actually gonna dock this over here on my second monitor so that I'm not referring back and forth. So let's write a new comment, create and initialize store item pants. Okay. So we're going to make a new store item. And we're going to call it item 2. Okay. Now, because I'm lazy, here's what I'm going to do. I'm going to copy these lines, throw them over here, change all the instances of 1 to 2. And I will change this to pants 25 and 15. Okay. We're going to do the same thing again for shoes. Okay. Create and initialize store item shoes. It's going to be of type store item. Call it item 3. I'm lazy. Put them here. Call it shoes. We have 30 of them. And the price is $20. Okay, awesome. Now, by doing this, we created 3 store item objects. Item 1 contains 3 members of string, int, and double. So does item 2. So does item 3. Okay. Now this is a more structured way of containing our data, unlike the 3 array thing that I showed you before. Okay. So let me go back to the PowerPoint. What else did we have to do? Okay. So, yeah, we did this. All right. Lecture activity 6, part B. Creating a vector of structs. All right. Now push all the 3 items into a vector of structs and name it inventory. Okay. Then write a user-defined function that prints a vector of store item. Okay. So, actually, before we move any further, you might be wondering how exactly we would how exactly you would want to like change these variables. Like, so if I wanted to see out item 1's item name, what I would have to do is go over here and say see out item 1. Item 1 refers to shirts, remember that. And then I have to say use the dot operator and say item name. Okay. And by doing this, if I ran this right now, none of this you would see, but you would see this. So if I ran this, you would see shirt being outputted, right? Yeah, you see shirts. And then if I wanted to output something else, like let's say I wanted to output how many shoes I have. Look, so I would say something like see out I have this many shoes. And I would say item 3, because item 3 refers to shoes, right? And I'd use the dot operator and say how much they are with quantity, okay? If I ran it again, oh. What happened here? This didn't work. Oh, my bad. One thing I forgot to do is change every instance of 2 in here to 3. So when this was 2 before, I actually overwrote this, and item 3 actually had 3 uninitialized variables. So that's the issue with dealing with variables that are not initialized. So just be careful of that when you're writing your programs. You never want to fool around with uninitialized variables. But if I ran this again now, it would you would see it working. So yeah, I have this many shoes, 30. Okay. So now that you know how to struct works, let's delete this. and continue on with the lecture activity, okay? So, yeah, push all of these to a vector of structs and name it inventory, okay? So it looks like I'm gonna have to go up top and include vector, okay? So with that, we can begin writing our vector of store items. So I'm gonna say vector of store items. So you already know how to declare a vector, right? So we're going to say vector. This is going to be of type store item. And yes, I can do this because store item is a valid data type now. And we're going to call it inventory. Okay? So we're going to take inventory dot push back, and we'll push item 1 to it, okay? We're going to do the same thing again for item 2. And we're going to do the same thing again for item 3. Okay, great. So the last part of the lecture activity is to then create a user-defined function that prints a vector of store item. Okay? Now this is going to be very similar to what we've been doing before with vector strings. So we're going to make a new user-defined function after our int main. Okay? Let's call it, it's going to be a void function. So void. And let's call it print vector. Let's say SI, which is short for store item. Okay. Now this is going to accept a vector of type store item. Yeah, that's the convenience of having this be a valid data type now. I can do stuff like this. And we're going to call it V. Now, one thing that's very important, I discussed this in the pointers and iterators lecture, because a vector of structs that can be pretty large, okay? What if you had 100 or 1,000 store items, right? When you pass it to a user-defined function, you don't want to make a copy of that and needlessly waste space. So what we're going to do is put the address of operator here and pass it by reference. That way this program runs more efficiently, okay? So here's what I had in mind for printing this vector. So for each of the 3 items, we need to output its name, its quantity, and its price, okay? So down here in the definition, here's what I'm going to do. Let's make a for loop. Call it int I equals 0. I is less than v dot size, and I plus plus. Okay. Let's see out the item name. Okay. Now the way you would access members of a vector is I named it v. So in order to access it at position I would say v, and in square brackets I put position I. Okay. Now, because this is a struct item, I would need to use the dot operator to access the individual members. So I'm going to say vi dot item name end line, and then I would see out the price. The price for this item is going to be v at position I dot price. Okay. And then the quantity, I would do the same. Quantity. Hold on. Oh, my bad. I listed quantity first, then price. It's better to be consistent. So I'm going to change this to quantity. Change this to quantity. Change this to price. Oops. Price. Be at position I dot price. And then let's end the line. Let's end the line again outside the for loop, so there's space. Okay. All right, so what I'm gonna do now is I'm gonna have a section here called cout. Let's call this part B. Sorry, I keep switching back and forth. Creating a vector of structs. Okay, so creating a vector of structs. So we're gonna use our print function. So print vector si, and we're gonna pass our vector store item called inventory to it. And that should output each of these 3 items that we created and initialized. So let's see it. Error. Okay, let's see. Let's see what's wrong. Oh. See, vector print I identifier not found. You see, I forgot to put the function prototype. My bad. So let's get this and put it right here. Add the semicolon, delete the variable name. Now, I'm actually, there's actually one thing that I need to mention to you about the C++ compiler. Now, you see, I have this struct item and this this function prototype here. Now, because this function prototype includes an instance of store item, the compiler actually needs to see the definition of store item first. So the proper way to order this, like this thing and this thing, I would actually have to put this function prototype after the definition of the struct. And by that I mean is, oops. If I actually did it this way, when the compiler reaches line 6 in the program, because the compiler steps through line by line, right? When it reaches step 6, when it sees store item, the compiler is going to say, oh, I don't know what that is, because it won't know what store item is until line 8. So if I ran this now in this order, this would actually crash my program because it wouldn't know what store item is at line 6. If you wanted to see that. Yep. So that's something that you keep in mind when you're writing your struct definitions and your user-defined function prototypes. The order in which you put them is important if they include instances of each other, okay? So I'm actually going to put this back over here where it belongs. And you should find that this works now. Yep. It works exactly how we intended it. So we actually have the makings of a very good program that we can use to that a person who actually owns a souvenir store would actually pay you to write. It doesn't do anything yet. There's no feature to add or subtract store items. Like, let's say the store decided to stop selling shirts or pants, and there's also no feature to add new items, but we could add those eventually if we were creative enough and wrote the C++ code in order to do that. Okay, but all we did here was we were able to store the data that the program needs to contain. Okay, so this is very good programming practice for you. So now that you know what a struct is, we can start talking about classes. And classes are actually a really, really huge thing. In fact, what I have planned, this lecture video might end up going like really far beyond the normal intended length, because classes are a huge thing. But we'll see. Let's put you like this. Okay, so we did A and B. Okay, so now we're going to talk about classes. Okay, now the reason why I wanted to talk about structs first is because it would help us visualize classes better. Let's just get down to it. So a class is another form of structured data type, and they are declared with the following syntax. You have to use the keyword class. You have to use you have to identify it the same way we did with the struct, and just like a struct, we in squiggly brackets we have a class members list. But for structs, it was a struct member list, but for classes, it's a class member list. Okay. Now, I know I've said this many times, but classes can get really, really long. Okay. Now, because of how large code for a class can get, it is good programming practice to put it in a header file instead of your main.cpp file. Doing this keeps your code more organized, and it keeps your code less cluttered. Okay. You will see how large a class can get when we actually get down to the lecture activity. Okay. Now, even though classes and structs accomplish the same task, they hold data types that can be of different data types. There is one main difference between a struct and a class. Okay. For classes, member variables can be made public, which means that it can be accessed directly, or they can be private, or in other words, they can not be accessed directly. Okay. This adds a layer of security to the classes that you're writing. Okay. Now, you can declare which members can be public or private using the keywords public and private. Okay. So over here is just this is another version of the class syntax that I wrote in the previous slide, but this time over here in public we have the public class members list, and then over here in private we have the private class members list. So some variables are public, other variables are private. Okay. Now one thing I noticed is that I actually made a mistake when I was writing this. So private members should be should private members be listed first and then public? Oh, actually, no. This was right the first time. My bad. Yeah, this is correct. Forget what I said. Okay, so let's continue on. So, data variables that are members of a class are called class member variables. These should always be private. Okay. User-defined functions that are members of a class. Yes, that's true. You can have user-defined functions be members of a class. This adds to how powerful classes can be. Okay. But functions that are members of a class, they're called class member functions. These should always be public. Okay. Now, so for private members, so if a member is declared private, you wouldn't be able to access them or change them directly. So how would you change variables that are declared private? So private members can be accessed / changed indirectly using setter functions and getter functions. Now, setter functions are class member functions that accept an input and sets the value of a private member equal to that output. Setter functions are always of type void. Okay? Getter functions are class member functions that return the data of the private member that must be accessed. Okay? The data type for these functions, they must match the data type of the object that they are getting. Now, when I learned C++ in community college, I always learned them as setter functions and getter functions, but I didn't learn until after I transferred to CSUSB that the more correct terms are mutator functions and accessor functions. Those are the terms that people use more often, okay? I just thought I'd include them in here, but from this point on, I'm going to refer them as setter and getter functions because that's how I learned it. Now, here in this gray box is the syntax for a class member function. So you'll find that this is actually almost exactly the same as the syntax for a user-defined function. The only difference is that you have to have the class identifier and then : before the function name. This is to indicate that this function is actually a member of the class that you're writing, okay? So this is the only difference, okay? Now, so that might be a relatively new thing for you guys to learn, like public and private. I'm not sure if you've seen that before now. A question you might be asking at this point is, why would you want to make certain members private and others public? So to answer this question, I want to discuss a little bit about information hiding, okay? Now, the reason why you want to make members private and others public is because this is for added security, okay? So, this is all technical jargon that a computer programmer knows and a computer programmer understands. So, when a user uses a program that you wrote, they only need to know what it does. They don't need to know how it does it, okay? Now, and that's the way it should be, okay? Now, it's good programming practice to make members of a class private so that the user, the person using your program, they don't have direct access to the class member variables, okay? Because if the user has direct access to these types of things, and if they can directly change these variables in any ways they please, there's an increased likelihood that the program might go wrong or crash, okay? So it's not just a question about security. It's to make the program that you're writing like a little more, I don't know, idiot proof as for lack of a better term. And this doesn't just count for the users either. It also goes for other programmers that you might be working with. So in case you didn't know, if you ever become a software engineer for a company, you're always going to work with a team of other programmers, okay? You're never coding something by yourself, because coding a project or a GUI or an app, that can take hundreds of thousands of lines of code. So it's impossible for one person to do it alone. So you're always working with a team, okay? Now, when you're programming as a team, you're always collaborating. And one of the difficult parts is that when you code with other programmers, there's no guarantee that they might use your code the way you intended. So making member variables private ensures that the classes that you write operate the way that they're intended. Okay? So if you're asking why you make certain members private and others public, that's the reason why. Okay? So, I understand that I threw a lot of information at you, but it'll make better sense when we actually begin this next part of the lecture activity, which is creating and using a class. Okay? So we're gonna write a class called person type. Okay? So this stores the data of a person, and this is actually, if I go back over here, your lab 3 is going to require 3 classes in order to work. One of them is person type, which is what we're going to write this week. The other ones are student type and faculty type, which we will write in a later date. Okay, so if I go back, okay, so we are writing a class called person type, and it contains 3 variables. One is a string called first name, the other is a string called last name, and an int called age. So what I'd like you to do is think of this as the same as a struct, where we're holding multiple data types, but we're doing it in the form of a class, and the class is just a more powerful version of a struct. Well, that's putting it simply. Classes are very, very powerful, but you'll see that eventually. So after we create this, so it looks to me like we have 3 data type members. So these 3 variables, they would actually be private because we don't want the user to access them directly. Okay. Now, the next part is we need to write setter and getter functions for all 3 of these variables. So we need to write a setter and getter function for all 3 of these. So that means we have to write 6 functions. Okay. Now, another function that would be useful is a print function that counts all 3 variables so that we can see what they look like for the sake of debugging. And then use the class by declaring 3 variables of type person type. Okay. So it's time to get down into this and begin writing our very first class. Okay. So let's go back to Visual Studio. Okay, so this is everything we have for structs, right? Now, if you go back to the PowerPoint, I said something here. So, because of how large code for a class can get, it is good programming practice to put it in a header file instead of your main.cpp file. Even though we could write the code for our class in our main.cpp, like we would stick it in here, like between our using namespace standard and our int main. That's not good programming practice, especially when the code gets very, very long. So here's what I'd like you to do. Let's create a header file, okay? So over here in your Solution Explorer, right-click Source Files, hover over Add, click New Item. Now this is important. Instead of choosing .cpp file, select header file .h and name this person type .h. Okay. So we're gonna add it. So this is our person type .h. Okay. If you click on these tabs over here, you have your main.cpp and you have your person type .h. One thing that I'd like you to do is pull out this tab and use this widget here to dock it over here. So now you can see your main.cpp and your header files at the same time. That's pretty cool, right? Now, so the very first thing that you might notice about this header file is that it has this pound pragma once here. Okay, you might be wondering what that does. So, I don't know if this is a feature that's in all IDEs, or maybe it's just a feature that's in Visual Studio. But the purpose of this pragma once is so that header files or libraries do not get added multiple times, okay? So what I mean by that is, because this header file is going to need a couple things. It's going to need IOStream, include IOStream, and it's also going to need using namespace standard, because I don't want to write std : in front of all of my cins and couts. So I'm going to use using namespace standard. Okay. Now, if I didn't have this pragma once here, what would happen as a result is that when I go to my main.cpp, in order for me to use person_type.h, I would have to include it the same way I would include a library. But because this is a library that we're creating, instead of using chevrons, we would have to use quotes. Well, double quotes to be exact. So over here, I'm going to say pound include, and I'm going to say in double quotes person type.h. Okay. Now, because the main.cpp already has IOStream and using namespace standard, what happens as a result, if I didn't have this pragma once here, what would happen is that I would be adding these libraries twice to my main.cpp because it's included in the person type.h. That would actually crash my program because I'm adding the same library twice. This pragma once prevents that from happening. Does that make sense? And I didn't mention that in the lecture PowerPoint, so maybe just write that down in your notes somewhere so you don't forget. But anyways, we should get down to writing our person type.h. So as I can see, so one other thing that you need to include is string, okay? String. Okay. Let's put these all here. Now, the syntax for a class. It's right here. We need to say class identifier, and then in squiggly brackets we put our public variables and our private variables, okay? So I'm going to say class. I'm not sure how well you can see. Would it help if I just move this over here? And then we'll look at our main.cpp later, okay? So we're going to have a class. We're going to have a class identifier, and we're going to call it person type. Okay? Now, as always, there are two keywords you need to include. The first one is public. The second one is private. Now, if you go back to the PowerPoint, you can see that I said data variables are called class member variables. These should always be private. So what that means is our string first name, string last name, and int age, they should all be private variables, okay? So under private, we're going to have a string called first name, a string called last name, and an int called age, okay? So now that we have these, what we should be doing next is we need to write setter functions and getter functions for all three of these variables. So 6 functions in total, okay? So I'm going to go back to my class, and I'm going to put some comments, okay? I'm going to call this setter functions, also called mutator functions. Okay, now one thing you need to know is setter functions are class member functions that accept an input and sets the value of the private member equal to that input. They must always be of type void. Okay, so the way I'd like you to think of this is, do you remember the way we wrote user-defined functions before? This is almost the exact same thing, except we would have to put the function prototypes here inside of our class. Oops. And then the function definitions, we would write them on the bottom, and the only difference is we have to put the class identifier : in front of the function names. Okay? So let's write our setter functions, okay? So they're always of type void, okay? And we need one for each of these. So I'm going to say void, like we're going to use, I like to use this naming system so that it's easier to keep track of. So I'm going to say set first name. Now, this is going to be a setter function that accepts a string, and it will set first name equal to whatever string is, okay? We're going to have a setter function for last name as well. Set first name. Also of type string. Well, it accepts a string. And then another setter function for age. So set age. And this is going to take an int, okay? It'll take an int and set age equal to whatever int we pass to it, okay? So those are our setter functions. Well, the prototypes for now, all right? Now we need to write our getter function. So getter functions, also known as accessor functions. Okay? Now, these need to match the data type of the object that they're getting. So these are class member functions that return the data of the private member that's being accessed. Okay. So, going in order, I'm gonna need a string, and an int. So I'm gonna say string get first name. And this is a function that accepts no parameters because all it's doing is returning first name, right? We're going to have another one called string get last name. And then an int called get age. Okay? And let's just say last name, semicolon. Okay? So, what we need to do now is define these functions, because these are user-defined functions, but they're members of the class, okay? They're members of the class person type. So here are all the function prototypes. What we need to do is write the function definitions now, okay? So here's how we would go about doing that. Let's copy this, and you always know where to put the function definitions, right? You would put them on the bottom where it can be accessed, okay? So I'm going to delete this comment and this comment, okay? And, well, let's actually say these are setter function definitions, okay? And these are getter function definitions. Okay. So, what we need to do is delete these semicolons here. Okay. Now, as with according to this class member function syntax, what we need to do is put the class identifier and then : in front of function name. Okay. So here's what I'm gonna do. It's called person type, right? So I'm going to say person type : okay, in front of each of these function names, okay? Here, 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 and here. Okay? Now, what's left now is that I need to put squiggly brackets and then statements which define these functions that I'm writing, okay? So, squiggly brackets, here, 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 and here, okay? So, because if you declared in your int main, if you ever declared a variable that's of type person type, it has 3 variables: first name, last name, age. You wouldn't be able to access them. You would have to use the setter and getter functions that you wrote in order to get them. Okay. So for these setter functions for first name, last name, and age, this accepts a string variable. And it sets first name equal to whatever the string is. So because this is a function definition, I would have to, in the parameter list, give the variable's name. So to keep it brief, I'm just going to call this variable s, okay? So this is a function that takes a string variable, okay? In the definition, we'll call it s, and we're going to set first name equal to s, okay? We're going to do similar things for the other setter functions, okay? So in this parameter list, let's call the string s again, and we're going to set... Oh, I made a big mistake here. This is supposed to say last name. My bad. I just realized that. So this should be last name. Okay. So I'm going to set last name equal to the string we're passing s, okay? And then the last is the age, okay? Let's call this int I, okay? And we're going to set age equal to I, okay? Okay, perfect. Our setter functions are written already. Now, it wasn't that hard to make a setter function now, was it? Okay. Now, writing the definitions for the getter functions, that's actually going to be easier. So I'm going to say, we're going to use the return keyword here. So, because these are supposed to return a type string, and type int respectively. So this is supposed to retrieve the last name, okay? Oh, first name, I meant. So we're going to say return first name. Over here, we're going to say return last name. And over here, we're going to say return age. Okay? So here's my class now. I have all of this, and my setter and getter functions are already written. Okay? Now, what else does the lecture activity ask us to do? So, our setter and getter functions for, okay, we did this. Now we're gonna do this. Now, the only reason I wanted to write a print function is because I just thought it'd be useful later on down the line. So let's write another function called print that counts all 3 variables, okay? So I'm gonna zoom in again. Under public, let's write the prototype for another function, okay? So print function, okay? Now, this print function, like all of our other print functions, it's going to be of type void again, okay? Because it's not returning anything. And let's just call it print. Now, all of these are functions, so they have to have open parentheses, right? So print needs an open parentheses. I'm going to put a semicolon here. So now, let's define what print does, okay? So like I said before, it's good programming practice to have your function prototypes in the same order as your function definitions at the bottom, okay? So I'm going to put my print function here. I need to put person type : in front of it again. So I'm going to do that. We will delete this semicolon and then put squiggly brackets, okay? Now, there's many different ways we can print this, okay? But the way that I'm going to do it is I'm going to see out, let's say first name, : chevron, and we will output the first name, okay? We'll do the same for last name, last name, and it outputs last name. And then it has to output age, so I'm going to say age. Age should probably be capitalized. It'll look nicer that way. And then I'm going to say age. Okay, so that's it for my print function, okay? So it looks to me like this class that we wrote together, it's ready to use in our main.cpp, okay? So here's what I'm going to do. In our person type.h, I'm going to scroll down slowly in case there's anything that you missed, okay? But your person type.h should look like this, okay? Okay. So I'm actually gonna pull out this tab and put it back here, and then let's focus on our main.cpp now, okay? Now, we include person type, which means that this class, person type, is ready to use, okay? So, use the class by declaring 3 variables of type person type, okay? So here's how we would do that. Well, actually, first of all, let's end some lines. So we have space between our sections. Well, let's end 2 lines. Okay, so we're gonna see out, call this part C, okay? Part C is creating and using a class. Okay. So, person type's ready to use. So let's declare some variables. The first variable is going to be of type person type. And let's call it person A. Now, do you see that person type is now a valid data type that the compiler recognizes? This is the power of classes, okay? It does the same thing that a struct can do, except it's more powerful and it's more versatile. Now, how powerful and how versatile it can be completely depends on what kind of functions, what kind of features that we can add to it, okay? So, going back to our main.cpp, I have a person type called person, okay? Now, right now, person A, it has 3 private functions. Actually, 3 private members, okay? One is a string first name, one is a string last name, and int age. Now, currently, they're not initialized, okay? Now, what we should do is initialize them. Now, I'm going to say person A. Now, because because first name, last name, and age are private, I actually can't say person type dot first name equals, no. I can't say, I can't use the dot operator to set them. See? First name and set that equal to what do we want to set it equal to? Let's call it, let's say this person A's name is, first name is Jane, and person A dot last name is Doe, and then person A dot age is 25. Okay, now I can't, as you can see, these are errors. I actually can't do this. Okay, now the reason why I can't do this is because first name, last name, and age, they're private variables. They cannot be accessed directly by the user. Okay, this is the added layer of security that I'm talking about when you're featuring your program to whoever's buying it, or if you're working with a team of programmers and they're helping you build your code. Okay, you can't access them directly. Okay, now the way you would have to set these variables is that you would have to use your setter functions. That's actually what the setter functions are for. Okay, so instead of doing this, like, well, first let's demonstrate this. If I ran this, it'll be an error. Okay, it'll crash because it'll tell me, yeah, it's inaccessible because they're private, which makes sense. Okay, so here's what we're gonna do instead. Okay, let's use our setter function. So set first name, and because it's a function, it needs parentheses. Okay, now set first name. If you go back to your person type.h, I'm going to dock it right over here. Set first name accepts a string called s, and it sets first name equal to s. Okay, so whatever variable we pass, whatever string variable we pass into this, it's going to set first name equal to the string we pass. So let's do what we've been trying to do before. We're gonna pass Jane into it. Let's set the last name now. So person A dot set last name. Your last name is Doe, and then person A, and then we're gonna use set age. Okay. Oh, my bad. This is supposed to say set last name, not get last name. And then set age. Your age is going to be 25, okay? Cool. So, now I have a person type called person A, and its first name, its member variables. First name is Jane, last name is Doe, the age is 25. And if you want me to prove that to you, one thing that I could do is see out person A dot get. I'm using my getter functions now. Get first name. And then I could repeat this same line for get last name and then get age. But that's a little cumbersome, and this is actually the reason why I wanted to add the print function. Okay, the print function will do exactly what we told it to do, and just see out first name, last name, and age. So instead of doing this, we can just say person A dot print. So now we're using our print function for person A. Okay. Now, if you wanted to see this, I'm going to run it again. Okay, so we printed person A's contents. Their first name is Jane, their last name is Doe, and their age is 25. Okay? So, congratulations, you've just finished this next part of the lecture activity. Well, almost. We actually need to declare 3 variables of type person type. So we already made 1, okay? So I'm going to delete this print function for person A. And let's create 2 more person types, okay? So person type person B. As I'm going to say person B dot. We're going to actually repeat the same thing that we did for person A, okay? So set first name. What do we want to name him? John Doe. So John. Oops. Person B. That's set last name. We're gonna set you to Doe. And then person B dot set age. Let's pass a different into it. Let's say that he's 20 years old, okay? Okay. So here's person B. Now, we need to make one more person called person C, okay? So I'm gonna, because I'm lazy, I'm just gonna copy this and put it here. Change all instances of B to C. And now, here's the fun idea. Let's put, why don't you put your first name and last name into this? Okay? So I'm going to put my first name, Lawrence. I'm going to put my last name here, Orijuela. And for age, you don't have to put your actual age. Just make up any number. I don't want to know what your real age is. Okay? And that's for ethical reasons, okay? But if you wanted to know my age, I'm actually 25, okay? So this is our person A, our person B, and our person C, okay? Now, you wouldn't be able to see this unless we outed them again, but that's actually what lecture activity part D is for. So creating a vector of classes. So if you look back in the previous lecture parts, we created and used a struct, and then we created a vector of structs, okay? For classes, it's the same thing. I want you to create and use a class, and then create a vector of classes, okay? Push all 3 items of person type to a vector of type person type, and name it individuals, okay? Then we'll write a user-defined function that accepts and prints a vector of person types, okay? So here's what I want you to do. You already know the syntax to declare a vector, okay? So we're going to say vector, and we're going to use person type. Right? And we're going to call this vector individuals. Okay? Now we're going to use individuals, and we're going to use the pushback feature. So we're going to say individuals dot pushback. We're going to push person A. We're going to push person B and person C. Okay? So now the vector of individuals has 3 members. Okay? So let's make a new section. I'm going to say, I'm going to say cout. This is part D. Creating a vector of classes. Okay. Did I capitalize it when I was... No, I didn't. I'm just trying to be consistent. Vector of classes. Okay. So we need to make a brand new user-defined function that accepts a vector of type person type, okay? So I'm going to scroll down to the very bottom. Let's make a new user-defined function. Let's call it void print vector. Let's call it PT, which is short for person type, okay? It's going to accept a vector of person type. And we're going to have to pass it by reference because, once again, a vector of classes, that can get pretty large pretty fast. And because we don't want the function to make a copy of it, we're going to pass by reference for the sake of saving space, okay? Now we're going to call this vector v. Now in squiggly brackets, we put our definition. So for int I equals 0, I is less than v dot size I plus plus. We actually don't need to put in the same work that we did for print vector store item. What we're going to do instead is that we're going to take advantage of the print function that we wrote before, okay? So at cout, well, actually not cout, because I'm actually not going to cout it because it's a void function. If it were any other data type, I would have to cout it, but because it's void functions can stand alone as lines of code, okay? So I'm going to say v at position I, and I'm going to use my member access operator or my dot operator, and I'm going to use the print feature, okay? Semicolon, and then lastly we're going to say cout end line, okay? So I will take this function prototype, scroll back to the top, stick it over here, okay? Add a semicolon, delete the name. Now, do you remember that thing that I told you before about the order in which you list your struct definitions and your function prototypes? The same principle here. Because the compiler steps line by line, the definition of person type is here on line 3. And this function prototype, because it includes a instance of person type, this line here would have to be listed after this line, which it is, okay? So bear that in mind, okay? But anyways, this function's ready to use. So I'm going to scroll back down to my int main. I know this is a very long video, but we've almost reached the end, okay? And I'm going to say print vector pt. This is my user-defined function, and I'm going to pass individuals to it. Okay? Now, this should now print all of the people that we push to person type. Okay? Let's try it and see if it works. Okay, perfect. So this is part A, creating and using struct. Part B, creating a vector of structs. Part C, creating and using a class. Part D, creating a vector of classes. Okay, so okay, thank goodness we are finally at the end of this lesson. Okay, now let's continue with the PowerPoint. So let me see something. Oh, so yeah, a couple notes actually. So even though even though this is your lecture activity 6, you're actually not going to turn it in yet, because if you look at the PowerPoint here, if you look at the tentative schedule, you're not going to turn in your activity 6 until October 23rd, because the thing is, we're taking a break for the midterm, and then after that, we're going to take another week to talk about structs and classes. Well, specifically, the thing that I want to talk about is constructors, which is all the way down here. And as you can see, I've yet to write the slides that I want to write for it. I'll write it eventually, but anyways, the thing is, you wouldn't be able to turn in your activity 6 until after we talked about constructors. Constructors were structs and classes. Okay? So here's what I want you to do. Do you see this? Your lecture activity? Don't turn it in yet. You're not supposed to turn it in until after we talked about constructors. So all of this, just save it for now. Don't submit it yet, okay? Because it's incomplete. So we've kind of reached the end of this video. So here's what I'm gonna do. I'm gonna go back to. I'm gonna zoom in so you can see it, and I'm gonna scroll down very slowly. And I want you to look at this and pause the video whenever you need, so that you can write everything that you need and make sure that there's no code or errors that you missed. Okay, so pause this video whenever you need so that you can write it down. Okay, and now here is the same thing but for your person type.h. Okay, so because you're not turning it in, just save it and close it for now, and we'll continue where we left off on October 16th. But right now there's bigger fish to fry. We have your midterm, which is actually coming next week. Okay, so let's take a moment to look at the practice midterm. Okay, if I can find it again. So you should have had like ample time to look at the practice midterm, because this is actually going to be very similar to your actual midterm. I know these questions look long, but they're actually extremely easy. In fact, I made these questions extremely descriptive so that it would be easier for you to follow the instructions and then answer these questions correctly. Okay. But yeah, I really hope that you if you didn't do these questions yet, I hope you at least looked at it, because the midterm is very important. It's actually more important than your lecture activities and your labs. Okay, because each lecture activity, there's 10 in total, is worth 2% of your grade. The labs, there's 4 in total, they're worth 5% of your grade, but the midterm's worth 25%. Okay, so if you had to prioritize anything, I would prioritize the midterm. Okay, so one thing that I'd like you to do now, because you're not turning anything in for the next week. Well, you actually do have things to turn in. It's your active and your lab too. But because I left this week clear, because I wanted you to focus solely on the midterm, okay? So, in the very next week, on October 9th, there's not going to be a normal lecture video. There is going to be a video, but it's not a lecture video. This video is going to be me answering all of the questions of the practice midterm. And I would like you to use that video as a reference for when you're solving the real midterm, because you're going to have... I'm going to post the real midterm on Blackboard on the morning of October 9th. And you're going to have an entire week to answer the questions of the real midterm. And then you're going to turn it in on October 16th. Okay? Now, because this is my first time teaching this class, here's the deal. When I was writing my practice midterm and my real midterm, I was showing my friends who are also computer science master students, and they all told me that all of these questions that I wrote, they're completely fair. They're solid questions. They cover everything, and they're very easy to answer. But, you know, that's just their opinion. That's also my opinion, too. This is my first time teaching this class, so for a beginner like you, it might be a completely different story. So here's the deal. Because I don't know how this midterm is going to turn out, one thing that I might consider is maybe, just maybe, this isn't a guarantee, but maybe I'll move the turn-in date for the midterm exam to October 23rd. So maybe I'll give you 2 weeks to do to do the take-home midterm instead of just one. How does that sound? We can talk about it further, because I want as many people to pass this class as possible. But here's the thing. This is just an idea, okay? We can talk about it more on October 9th, because October 9th, that is the day that I'm going to host a Zoom meeting. And that's also the day that, actually, if I reopen that PowerPoint, this is the PowerPoint of last week. October 9th is the day that I'm going to host a Zoom meeting in which all of you are going to vote as a class, and looking at the real midterm, you will vote which question is the hardest, and we will complete that question as a class. Okay? During that Zoom meeting, we can talk about it if you want to have an extra week to do the take-home midterm, okay? Does that sound fair to you guys? But anyways, like, as you can see, it's 2 in the morning, and I have to meet with professors with my my master's project at 7:30. So I'm gonna wrap this video up here. Please email me or contact me on Discord if you have any questions. I want to be helpful to you guys, okay? Now, I know, like, I hope you understand and appreciate the fact that I put a lot of work behind all of these lessons. And even though it's hard, I wouldn't trade it for anything in the world. I really like my job as a professor, and I really like being a master's student, and I really like working on my master's project. So, yeah, we'll talk about it on October 9th, but until then, I guess I'll see you then. So, this is the end of this video, and I hope to see you all on October 9th.